All right, today we're working with 20.3 on similar figures. We're going to be combining transformations and understanding what a similar figure is. So in this case, when creating an animation, figures need to be translated, reflected, rotated, and sometimes dilated. As an example of this, apply the indicated sequence of transformations to the rectangle. Each transformation is applied to the image of the previous transformation, not the original, and label each with the transformation applied. So we're going to take this figure through a process of transformations, whether they're rotations, reflections, translations, dilations, etc. And we're going to compare the last rectangle that we create based on these transformations with the original to see how the shape, size, and angle measurements compare. So I'll use different colors as I go. For example, to begin with part A, it says that x and y should be translated by adding 7 to x and taking away 2 to y. So I will use a new color for this figure. So x plus 7 means that x is moving to the right 7 spaces since we're adding. So each of these vertices should move to the right 7 spaces. And then it'll also move down 2 because we have -2, meaning we're lowering. So I'll move from here 1, 2, 3, 4, 5, 6, 7, down 2. 1, 2, 3, 4, 5, 6, 7, down 2. Same thing here, 1, 2, 3, 4, 5, 6, 7, down 2. And the last one should be here also to create this perfect rectangle that we have as the pre-image. I'll label that A and a translation. Okay. Moving forward, then it says for part B, from this image to the next, we are going to leave x as is, but multiply times a -y. Let's see what kind of transformation that takes us to if you don't remember. So I'll use a darker color. X is going to stay the same, but we are going to take each of these vertices and make the y's negative. So x is going to stay at 1, but instead of 1, 2, 3, 4 positive, it'll be -4. Same thing here, instead of being 6 positive, it'll be -6. Instead of being 4 positive, it'll be -4, and again, -6. Since we're multiplying the y's times a -1. And this looks like a perfect reflection, right? Part C says that I should rotate 90 degrees clockwise around the origin. Clockwise tells me that if you remember the rules algebraically, I'm going to multiply my x's times -1 and then flip. So I'll actually write these coordinates for myself. First I have 5, -6. Then I have 5, -4. Then I have 1, -4, and 1, -6. If I multiply my x's times -1 and flip, because it's clockwise, I will have -5, -6, but in this case flip, -6, -5. This 5 times -1 would become -5, so I'll flip it to -4, -5. This would be -4, -1, and this would be -6, -1. So I'll plot those, -6, -5, -4, -5, -6, -1, -6, -5, -4, -1. And this should be my new image for C of a rotation. Then it wants me to translate again by adding 5, which means moving up on x, and then adding 3 to y, which means, moving to the right for x and up for y. So I'll start here, move over 5, 1, 2, 3, 4, 5, and up 3. 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 So D should be right there. And then E is telling me that this is a dilation, right? I will make this green to go along with what I'm working on, and a dilation of 3, meaning enlarging times 3. So this point times 3 would be -1, 2, so -3, 6. Oops, 6 would be right there. This would be +1, 2, so that would be +3, 6. Then I would have -1, -2, so that would be -3, -6. And this would then become +3, -6. And my dilation would be this large figure there for E. So list the coordinates of vertices for E. That would be -3, -6, -3, 6, 3, 6, and 3, -6. And let's take a look at how they compare the pre-image to the new image. So the shape stays the same. We have 2 rectangles. The size of E is 3 times larger than the original. And angle measurements would then also say the same, because we still would have 90-degree angles for each of these pieces, right? So the shape and angle stays the same, and the length and size would change by 3. So that's a process of reflections. These are similar figures then, E and D, because they match in shape and angle measurements, and their enlargement or reduction would just be a perfect proportion to the original image. So 2 figures are similar if one can be obtained from the other by a sequence of translations, reflections, rotations, and dilations. Similar figures have the same shape but different sizes possibly. So when you're told that 2 figures are the same, they are similar, they must be a sequence of translations that can transform one to the other. So if I looked at part A, this rectangle or square A, figure A, and tried to transform it to figure B, to tell if they're similar, I would have to take it through a sequence of transformations and see if that would match. So both figures are squares. So then I already know that there's no rotation needed because they're both squares. Figure B has sides twice as long as figure A, so I know that the dilation is times 2, right? Because this is a length of 4 and this is a length of 2. That means it's 2 times greater. And I know since it's a square, this would also be 4 and this would be 2. Figure B is moved to the right and above figure A, so I do need a translation. And then to accomplish this, I need to use a factor of 2 followed by a translation. So a dilation first to make it larger, and then a translation that would add 4 and add 6. And then I would be able to tell that the figures are actually similar, not congruent, but similar. Congruent would mean that they're exactly the same size, but in this case they're not, so they're similar figures. So looking at part B, we want to identify a sequence of transformations that will transform figure C into figure D. Include a reflection, so specifically directed, tell whether the figures are congruent, tell whether they are similar. So if I'm looking at D, I'll just follow along down here. I can see that D is reversed, right, from that of figure C. So as a reflection, they're going to need to be reflected over the y-axis. Figure D also has sides that are half as long as figure C. Here we have a length of 2. Here we have a length of 4. Same thing here, we have a length of 4. Here we have a length of 2. So we can tell that we need a dilation with a factor of half, because we want to transform C into D, meaning we're going to cut it in half, reduce it. If I was moving from D to C, I would obviously enlarge then, and I would have a scale factor of 2. So it's really important to know which figure you are moving from and which figure you are moving to. Figure D is also moved above figure C. So that means that a translation is needed from this one to this one. And in that case, the sequence of transformations that we have is to first begin with a dilation of a half scale factor. Then we're going to reflect over the y-axis by multiplying all the x's by -1. And then translate by moving C up to where D is by adding 5 to our y's. The figures aren't congruent because they're not the same size, but they are similar because they have the same angle measurements and they are the same shape. So what you have to do is make sure that you are taking all of these sequences of transformations carefully from the first figure, the pre-image, to the new image, and make sure that you follow well enough so that you can actually determine whether they are similar or congruent. So what you want to make sure is that now as you move forward into the rest of the lesson with your homework, that you're following along as far as whether these images are similar or congruent. And the only way to do that is to take them through a series of transformations, reductions or enlargements with dilations, translations, reflections, and rotations. And remember that Module 19.4 had some great directions on how to do that algebraically. So here for your homework, I know that there's a section about angle measures of the actual sign. If you have a protractor, great. If you don't have a protractor, feel free to skip what you have to, but everybody should have some sort of measurement tool at home for the lengths of the sign. Some of this can be found online as well in apps on your phone too. And then for exercises 7 through 10, it says the transformation of a figure into its image is described. Describe the transformations that will transform the image back into the original, then write them algebraically. Do your best to write them algebraically. That means including your direction in the coordinates like we've been listing them, but also describing. Good luck.